1.5. Mine looks a little bit different than yours. I don't know what I did with the document that I posted in yours, but this is slightly different, but it's really the same. Yours just doesn't have that title up at the top. Inequalities, okay? We know inequalities. You guys have done inequalities. You've done a lot with inequalities in Algebra 1. We're going to go back there. So we're going to start with translating inequalities, and translating, right, that just means like, how do I turn these numbers into words, or how do I turn these words into numbers and symbols? So the first one, the first inequality that we're going to take a look at is this. Okay, can anyone tell me how you would say that?
X is greater than 4.
X is greater than 4. Okay, X is greater than 4. And the way you would graph that, hopefully you know this already. Here's a 4. What kind of dot do I put at 4? Open, right? 4 is not included in my answer, so it is an open dot. And then greater than is going to the right. X is greater than 4. Here's the trick, guys. Actually, I'll tell you the trick in a minute. This one. X is less than or equal to 4 is X is less than or equal to 4. Okay? When you graph that, what kind of dot? Closed dot. Here's the trick. Well, this isn't the trick. I have another trick. When there is a bar, that means we are including that number, which means when we graph it, we want it filled in. Okay? Here's the trick. Whatever way your symbol opens up is the way your arrow points. So up here, if I turn this into an arrow, it's pointing to the right. This one, if I turn it into an arrow, it's pointing to the left. That trick only works if your variable comes first. If your variable is not the first thing you see, then don't use the trick. But if you put it so that your variable is always first, you may always use the trick, okay? So if X is less than or equal to 4, you go to the left. Anybody feel like singing right now?
No.
Guys, I'm so sad. I used to, when I would teach this lesson and I would say to the left, my whole class would sing to the left, right? Nobody does it anymore. Do you know what that means? It means I'm old. It means I've been doing this for too long. Okay. Next thing, open circle versus closed circle. We already addressed it, but here it is. An open circle is when there is no line, no bar under your inequality, right? Less than or greater than means your answer, your number, is not included. Okay, we are not including the 4 when it's an open dot. We are including that 4 when it's a closed dot. So closed circle, closed dot is less than or equal to or greater than or equal to. That means you are including the number that is in your answer. Okay? Any questions on that part of it? Okay, so one thing to watch out for when you are translating inequalities is there are 2 different setups. There's the we are working with an inequality setup, or there's the we're just doing an operation setup. Let me show you the difference. It says 4 is greater than a number. We would write that 4 is greater than a number, right? The operation says this: a number is 4 greater than 15. What does that look like? Equals.
4 greater than 15.
Right. So a number, n, is equals 4 greater than 15. Okay? Those are different, right? One's an inequality, one's an equation. Pay attention to the wording. The wording will tell you what it should be. Okay? So let's translate a few. This first one, number 1, 5 fewer than a number is at least 12. Now, at least can be a little bit tricky. I want you to try to write that out how you think it should be written. and then I'll tell you if you're right. And if you want to check with your neighbor, feel free to check with your neighbor. 5 fewer than a number is at least 12. Side note for those of you that are like, I don't know what the heck this is right now. Think of this as the word less, fewer than versus less than. It's pretty much the same thing. Maybe that's helpful. Did you get the same thing as your neighbor?
The least is throwing me off.
Mm-hmm. The least does throw you off. You got to stop and think about, what does that mean? Okay, someone tell me what they got. Yes. Okay, Aiden's got it. He said, and I don't care what your variable is. He said n, you could say x, you could say v, I don't care. N, what did I just say? Minus 5 is greater than or equal to 12. Okay, so here it is. Less than, right? That's the one that swaps things. That's a minus sign, okay? 5 less than a number is n minus 5, but then it says is at least. And so many people want to write less than or equal because they hear least and they think less than. But think about it. They're saying this is at least 12, which means it's 12 or it's 13 or it's 14 or it's 15. So that is greater than or equal to 12. Okay, it could be 12, which is why it has the bar underneath, but that would be your setup. All right, what do you get for the product of 7 and a number is no more than 50? Jackson.
7n is less than or equal to 50.
Yes. Okay, so 7 and a number, their product would be 7n, is no more than, which means it's got to be less than or equal to, because it could be 50, right? Not more than 50. So less than or equal to 50. Okay, questions on that? Okay, when you solve and graph, I want to show you the difference here. So we've done equations. When you solve an equation, divide by 2, divide by 2. When you solve an inequality, you do the same thing. It's as if you have an equal sign, kind of, okay? Divide by 2, divide by 2. What you get, they're doing something for class. They're not just like walking slowly for no reason. Yeah. So you get x is greater than 5 versus x equals 5, okay? You do solve them very similarly. I'll show you in a minute where there's something different. You should know that already, but I'll show you again. But when you graph them, if x is equal to 5, that graph would just be a dot at 5, right? Do I have to shut the blinds? Are they going to distract you right now?
Not distracting. It's just very funny.
Okay. This other one says x is greater than 5. So for x is greater than 5, here's 5. Is that an open or closed circle? Open, because there's no bar. So 5 is not included. What way do we go? To the right. Okay. That's the difference. Okay. Equations versus inequalities. Be careful when you're graphing that you are graphing inequalities, not equations. But the solving portion of it is the same. Okay, so here's what I need from you. When you solve equations or inequalities for me, I need these things. I need you to write the problem down. Now, with the exception of this, if you want to take a picture of it out of your book and drop in the one picture, not the picture of the whole book, the picture of the problem, okay, you may drop that in and work off of that. If you don't drop that picture in, write the problem out, okay? Then you need to show me all of your steps. Show me how you're getting there. Because if I can't see your steps, I can't see where you went wrong. And if I don't know where you went wrong, I don't know how to help you. So show me what you're doing. And then work down the page. Okay? Work vertically. Don't go 2x is less than 5. And then, well, you would go this way. And then your next step over here. It just doesn't make sense with math to work them out like this. Math is vertical. So do it vertically. Okay, so here's what we're going to do. We are going to vertically solve several inequalities. The first is this. Letter A. What would you do first here? Distribute. Well, yes, write it out if you're doing it in your homework, but I wrote it for you. So distribute this. Okay, you have negative 6x And then what?
Plus 13.
Plus 15. Thank you. Plus 1 is greater than or equal to 4. Okay? Now simplify. Combine your like terms. So negative 6x plus 16 is greater than or equal to 4. Take away the 16. So negative 6x is greater than or equal to negative 12. Stop right there. Alana.
So you said that you write them vertically, but like what if you run out of space for the right?
I mean, if you have like one problem where you ran out of space and you have to move it, go ahead and move it. That's fine. But you should most of the time, like don't write your numbers out and then do the work. Write number 1, do the work, and you should have plenty of room vertically. Number 2, do the work, and you should have plenty of space. Yeah. Yeah.
Can I take a guess at what you're gonna do next?
In a minute. I want to make sure everyone is fully aware of what's going on here. Is everyone done? Have this written down? Okay. Jackson, what should we do next?
Well, you're gonna divide by 6 regularly, but because you're dividing by a negative, the sign is gonna flip.
That's what I want you to see. Do you guys remember that?
Yeah.
If we divide by a negative 6, we have to flip our sign. Okay? So what was greater than or equal to becomes less than or equal to. So we get this. X is less than or equal to 2. And then you graph it. So here's my 2. Is this open or closed? Closed. And we go which way? Sing it. Yes. You're going to go to the left. Okay? Okay. Here's the thing, guys. I, in Algebra 1, would give you that problem. And then I'd give you another one like that where you have to flip it again. And I'd probably give you another one like that where you have to flip it again. But you guys know this already. You know you have to flip it. So don't forget, flip it for negatives. We're not going to do a bunch of those problems right now. Okay?
I have a question.
Yes.
How come you switch?
Because we divided by a negative. Whenever you divide both sides of an equation by a negative number or multiply, right? If you multiply both sides by a negative also, you have to flip the symbol, the greater than or equal to or less than or equal to. Okay? Every single time. Okay, letter B, and then I'm going to have you try the next ones on your own. Distribute this. I get 2x plus 6 minus 1 is less than 8. Simplify by combining the 6 and the negative 1. So 6 minus 1 is 5. 2x plus 5 is less than 8. Take away the 5. So 2x is less than 3. Divide by 2. I don't care if you write x is less than 3/2 or x is less than 1.5. They're both correct. I like them both. You pick. Okay? Now, if it's not a nice terminating decimal like that, then give me the fraction. But if it's a beautiful decimal, leave it. So if this is 1.5, this is going to be open because it's less than, and less than goes left. Okay. You try C and D, and then I will jump in and see what you did. Go ahead. So if you're confused right now, it's okay. It just means it's been a minute since you had Algebra 1. Here we go. Here's what you're doing. Negative 6x minus 2 is greater than negative 6x plus 7, right? What would you do next?
Cancel out the.
What do you mean by that? Add 6x. Yes, we're going to add 6x here, and we're going to add 6x here. That's 0. That's 0. Look what happens. Negative 2, is greater than 7. No solution. Okay? Listen. Hear me. When your variable goes away, we talked about this a couple days ago, right? When the variable goes away, there's one of two options. This option, you check, is that a true statement? Is negative 2 greater than 7?
No.
No. So your answer is no solution. right? There is no solution to that inequality. There is no number that works plugged into that inequality. Okay, now look at the next one.
Thank you.
And see if you can figure out what this answer should be. This one's a little different. Distribute this. We get 10x minus 15 minus 7x is less than or equal to 3x plus 8. Okay, now combine like terms. 10x minus 7x is 3x minus 15 less than or equal to 3x plus 8. What would you do next?
Cancel out the 3.
Take away the 3x's. Okay, we say those zero out. It's really tempting to say cancel because that's what every math teacher ever says. There's not canceling happening necessarily. It's zero, right? There's a zero there. So it zeroes out. We get negative 15 is less than or equal to x, to 8 is what I meant to say. What is that? It's true, right? When your inequality is true and there's no variable left, does anyone know what the answer is? Jackson.
Many solutions.
Infinitely many, essentially. We say it's all real numbers, okay? Remember that real symbol is the double line R, okay? So you may write that or you may write the word real, but it's all real numbers. How would you graph all real numbers?
Whoa.
It's the line, right? All real numbers. Because it's every number on the number line. So draw the number line again. All right. Last one in this first half of the lesson. And then we'll move on. This one, a word problem. Everybody loves word problems, right? It says this. A movie rental company offers two plans. The one plan, you can pay a $36 a month and rent as many movies as you want. Plan 1. Plan 2 says you can pay $15 a month and $1.50 per movie. How many movies would you have to rent in a month for the first plan to cost less than the second plan? What? I know, but if you get the second plan and you rent 2 movies, it's a bad deal. It's a real bad deal. Plus the $15. Oh, no, I said that backwards. If you rented, okay, I said that backwards. I was thinking they were the other way. If you rented a lot of movies, it would be a bad deal. We're going to find out how many movies would make it a bad deal. The trick with this problem, I think, is people see $36 a month and they think 36 times M. But look at what they asked us in the question. How many movies must you rent in a month? So we're only talking about 1 month. So if you want to put an M there, that's fine, but you're going to plug in a 1 for that. So the way we set this up is $36 a month would be the plan for 1 month for that first plan. Sorry, that's the purple. Okay, so one plan is $36 for the month. The other plan is $15 plus the $1.50 per movie. Okay, so the other plan is 15 plus $1.50 per movie you rent. So this is plan number 1. This is plan number 2. It says, how many movies would you rent in a month for the first plan to cost less than the second? What are we trying to figure out there? What's our inequality going to be? Who's talking right now? Is that Noah? Say it again. I can't hear you.
15 plus 1.59 is greater than 36.
Okay, so when comparing, right, it says how many must you rent in the first that costs less than the second. So I'm going to set it up the other way just so it's in this order, but she's correct. If you do it that way, it'd be greater than, right? I'm going to set it up in the order we have it. So 36 is less than the second plan, 15 plus 1.5 M. 1.5n, 150m, it's the same thing, okay? So I just take the 0 away, less to work with. So you would solve this, take away 15, and you get 21 is less than 1.5m, and then you'll divide by 1.5 or 150 if you like that better, and it will look like this. 21 divided by 1.5 comes out to 14. What is this saying? M is greater than 14. So in other words, you have to rent more than 14 movies a month for the one plan to be better than the other. Does that make sense? So you would have to rent more than 14 movies for the first plan to cost less than the second. It's a lot of movies in a month, right?
Get all the Marvel movies.
There you go. We're going through that right now. My boys wanted to watch all the Marvel movies, so
Oh,
they're going in order. It's kind of fun. Okay, I need you to stand up and cross your midline or shoot a bunny or something to just reinvigorate the brain. Actually, I don't know if they finished it. I don't think they did. They're on Iron Man. They have like 20 minutes left in Iron Man.
Which Iron Man?
The first one.
Oh,
We like just started. They're like, was that the third movie? Fourth?
That's the first movie.
No.
Are they watching
Maybe the first one was the maid. They're watching them chronologically. Yes.
Yeah, that's like
Chronologically.
It's okay, they have a couple ways to go. It gets.
Wait, no.
Marvel was first, right? Oh, America's first?
Well, are they
Captain
doing it
America
like?
was the first one chronologically. Captain Marvel was the second. If you count
Then
the
Iron Man.
those Agents of Shield.
Yeah, we're not doing all
We're
those.
not. Yeah. Wait, are they watching a timeline order?
Yeah, chronological.
This is right, but when we went over it, it was 20.
Oh, lucky you. You're off the hook. Thank you for being honest with me. All right. Here we go. I want to give you some time at the end to work. So let's do this. 1.5b is compound inequalities. These are the ones, if you recall from Algebra 1, they either have an and or they have an or in them, okay? We're going to talk about both, but they are different, and you graph them differently, and they look different, okay? So we're going to start with the ands, okay? These are all going to be and problems first. An and problem, leave him alone, Michael. You find all the values that make both things true. Okay, so it's not like this can be true or this can be true. It's saying this and this both have to hold true. So basically you're saying what's the overlap? What's the intersection of these two? And we'll talk about that in a little bit too, but if you want to just think, where do these intersect? That's an and problem. Where do they intersect? Okay? Okay, so if we're going to solve and graph, sometimes there's two different ways they'll set this up. Sometimes they'll actually put the word and in there. When they do that, you just solve it as two separate inequalities, okay? When they don't do that, that's C and D. I'll show you a better, quicker way. But for now, for A and B, you solve them separately. So we're going to start on A with that first part. We're going to subtract 1 from both sides. So you get 6 is less than 2x, and then you're going to divide by 2. So 3 is less than x. Now, if you like to leave it that way and you can graph it that way, that's fine. I feel like most people make mistakes when they leave it like this. It's probably better for most of you if you turn it around. So put the x first, but then you have to flip your sign, and 3, your symbol. So x is greater than 3, okay, is part of it. And on this one, divide by 3, you get x is less than or equal to 6. Okay, so if you're going to plot them separately, this would be great. For those of you that don't want to plot it separately and you want to turn it into one big answer, it would look like this. You would take essentially these two. 3 is less than x, which is less than or equal to 6. Okay, that's essentially an and answer. You may keep them separate, you may put them together. Please don't try to do both because you're going to mix something up. Pick one or the other. So you have a 3, you have a 6, 4, 5, 6. Okay, where is there going to be an open circle? The 3 or the 6? The 3. The 6 should be closed. So open at 3, closed at 6. And now here's the trick for you. Most and problems meet in the middle. There are a few exceptions, but in what you're going to be doing, just assume they typically meet in the middle. Okay? Or problems are like oars in a boat. Oars go out of the boat, right? Or problems typically go like this. So, and problems meet in the middle, or problems go out. But really, if you just graph what you see, you will end up with that. Because if x has to be greater than 3, it's going to go this way. And if x has to be less than 6, it's going to go this way. So we're just looking for where do they overlap, which is that portion right there. Jaden, did you have a question? Okay. Any questions on that?
You know how you flipped it? When do you know when to like flip the sign?
So this one I flipped just what it means. I kept what it means the same, right? This wasn't because we divided by a negative, we flipped it over. This was if 3 is less than x, then that means x is bigger than 3, right? So I'm just changing the order. And if I change the order of my x and my number, I have to flip that sign over as well. Because if you think of it that, let's just look at a number line here. Okay, if this is 3, and I'm saying 3 is less than x, then that means x is over here somewhere, right? Same thing here. If I say x is greater than 3, then if this is 3, x is greater than that number. Does that make sense? I'll try to keep saying it more as we do the next ones, and hopefully it will make more sense as we go. But we can always chat about that later too, if you want to. Okay, letter B, another and problem. We're going to solve them individually. So we're going to start by taking away the 2x from both sides. So we have just x over here and negative 1 over here. Okay, so we know this is true. X is greater than or equal to negative 1 if you flip it around, which I'll show you in a minute. This one, it's up to you if you want to move the x or you want to move the 4x. I'll just tell you, in my head, it makes more sense to move the x so that you don't get a negative, so that you don't have to flip the inequality. If you don't mind flipping the inequality and you're someone who's going to remember to flip the inequality, then go ahead and move the 4x. But so many people forget about it. So I would just subtract x here, and I get 3x, but then you also need to add 9 to move the 9 over to the other side. Okay, so this is gone. We're just left with 9 is greater than 3x. Then from there, we're going to divide by 3. So x, your symbol, and your 3, it looks like this. Okay, now this is an and problem. You're welcome, if you want, to flip them completely. So you could call this x is greater than or equal to negative 1 and x is less than 3. Okay, you could write it that way, or you can write it as one big inequality. If you write it as one big inequality, it's going to be negative 1 is less than or equal to x, exactly how you see it up here, which is less than 3. Okay, so don't do both of these. Either do this or do this. Who's so confused? Do you know where I lost you? Like, did you get how I came up with my answers? So we solved them both, right? And we got these two things. Those are our answers. It's just a matter of how you want to write it. So you could leave it just like that. Or you could put your x's first. If you put your x's first, it would look like this. Or you can write it as one big inequality, so there's just one x. If you're going to do it that way, that's this. So really there's 3 answers here. I don't care which version of those 3 you give me. Okay? Okay, when we graph it, you will have a -1, -2, no, not -2, 0, sorry, 1, 2, and 3. Are these open or closed dots? What do we got? Closed at -1 because it has the equal to bar. Open at 3 because it doesn't have the equal to bar. Okay? So if you look at this answer, it's saying x is between -1 and 3, right? If you want to graph them separately, then I would use this. X is greater than or equal to -1 is going to go this way. X is less than 3 is going to go this way. So your graph looks like that. Okay? Okay, C and D are easier in my head. You'll have to see if you agree with me. C and D, they're already set up as one big set of inequalities, okay? What we're gonna do is we're gonna solve it all at the same time. Simplify life. So you have to start in the middle. If I have 2x minus 4 and I'm trying to isolate x, what do I get rid of first? The -4. How do I do that?
Plus on both sides.
You add 4. Okay, so if I'm going to add 4 here, I have to add 4 here, and I have to add 4 here. Do it to all 3 parts. That gives me 2 is less than 2x, this is gone, which is less than 16. What do you do next? Divide by 2. And if you do it in the middle, you have to do it on the left, and you have to do it on the right. This gets you 1 is less than x, which is less than 8. And that's so much easier. I think that's so much easier. So you have a 1 and you have an 8. I don't really need all the hash marks in between. You can just put the 1 and the 8 in there. Open or closed dots?
Open.
These are open, and where do we shade? In between. Okay? You go ahead and try that last one. Letter D.
From both sides, right?
Yes. What 2 values did you get? -2 and +2. Yes. Okay, so let's work it out. Take away the 10. So you have to do that on all 3 parts. So you get -10 is less than or equal to 5x, which is less than 10. Then you're going to divide, but make sure you do it on all 3 parts. So you get -2 is less than or equal to x, which is less than, not equal to. Oh, you guys don't see that.
See what?
So my daughter was messing with my iPad the other day,
Uh-huh.
and, oh, that's interesting.
Wait.
See this?
Oh, yeah. We don't.
Yeah, you guys don't get that. How do I turn that off? What is that?
Tap the outside.
Oh, just tap outside.
The home button 3 times.
The home button 3 times?
Sorry, no, hit the home button 3 times.
Well, I hit the little bar and it says zoom out and it goes away, but it's just weird. I don't know. Okay, anyway, whatever. It's fine. So -2 less than or equal to x less than 2. You have your -2 and your +2. This is a closed dot because it's got the bar. This is an open dot because it doesn't have the bar. Where do you shade? In between. Okay? So those are and problems. Any questions on the and problems? Okay, the or problems. For or problems, basically it's saying, like, for instance, pick a shirt today. You may wear maroon or white. If you show up in white, are you correct? Yeah, right? So it's this or that. It doesn't have to be both are true anymore. It's not the intersection of the two, okay? So when we solve these, we solve them separately. They're totally exclusive of each other. This first one, take away 7, we get x is greater than or equal to -1. Or, what are we doing? Just listen, do the math. This one, we take away 8, and we get x is less than -5. Okay? Now think about that. If I were to plot these separately, which is what you're going to do, you have a -5 and you have a -1. The -5 is on the left, -4, -3, -2, -1. Again, I don't need all the hash marks. I just want you to see where we're at on the number line, so I'm going to give them to you right now. What you do here is plot these. X is greater than or equal to -1. So that's a closed dot at -1 and greater than or equal to. Okay? X is less than -5 is an open dot at -5, but it's less than. Less than goes to the left. That is your graph. Remember, the oars in a boat go out of the boat most of the time. Okay? Okay, so let's look at letter B here. Same idea. You have two inequalities with an or in between them. We're going to solve. So first thing is add 2 on this first one. We get 4x is greater than or equal to 16, and then divide by 4. So x is greater than or equal to 4. That's your first part. Or, now do the second part. Add 4. So you get 3x is less than or equal to -9. Then we're going to divide by 3. Do I flip it right now? Flip my symbol? No, because we're dividing by a positive, right? You only flip it if you divide by a negative or multiply by a negative. So we get x is less than or equal to -3. Okay? Now we plot. We need a -3, -2, -1, 0, 1, 2, 3, 4. Those are our two numbers. Open or close dots? These are closed because they have the bar. So a closed dot at -3, a closed dot at 4, okay? If we plot x is greater than 4 is this way. So that's an arrow to the right. X is less than or equal to -3, less than goes to the left. So that's going to look like that. Okay? Questions? Those are or problems. The ors are going out of the boat. Right? Okay. Last thing then are these special cases. Hopefully I left you enough room there before we get to the 1-6. Here's what I want you to write down about this, okay? And we kind of already said this, but or problems, we have everything as a possibility that we see there, right? And problems, we want the intersection of our things. Okay, we want where they overlap, where they meet up. So or versus and, okay? I'm going to give you 4 answers, 4 solutions to inequality problems, and we're going to compare how this would work, what it looks like. So let's say you solve a couple inequalities and your answers are this. X is less than 5 or x is less than 3. Give yourself a number line. If I were to plot these individually right now, I have a 3 and I have a 5. okay? If I were to plot x is less than 5, it would be an open dot at 5, and I would go to the left, right? Arrow to the left. If I were to graph x is less than 3, it would be an open dot at 3, and it would be an arrow to the left. Keep in mind, or problems include everything that's true in our graphs. So our actual answer to this problem, anyone think they know what it would be? If x is less than 5 and x is less than 3. Noah. The other one. X is less than 5, right? Because if I want everything that's true, this would be an open dot, and it would include everything this way, right? So my actual answer is x is less than 5, because if x has to be less than 3, it will be less than 5, right? But 3 should be included, because if x is less than 5, 3 is an answer. So you want what makes both of those things that will be not, I said that wrong. You want everything that's an option to be true. So that would be your answer, okay? Let's look at another or problem. So I would keep working down below. I'm gonna do the and stuff off to the right. Let's say your other one is this, x is less than 6, or x is greater than -2, okay? So I have a number line. I'm gonna move that down a little bit. Oh. Okay, here is -2. Here's 6. If x is less than 6, that's an open dot at 6, less than that, right? So the arrow keeps going, x is less than 6. If x is greater than -2, that's an open dot at -2, going this way. But we're not looking for where they intersect. We're looking for everything that's a possibility to be true. All real numbers. Was that you, Naomi? Who said that? Good job. This would be all real numbers, because we want everything that can be true to be true. So this right here makes -2 an answer, and this right here makes 6 an answer. So even though it's an open dot at 6, the other one would go through 6, right? That means my answer is the entire line, or all real numbers. Isn't that fun? So fun. Okay, so those are the or problems that are kind of unique. The and problems that are kind of unique are these, okay? Let's say one of your answers is this. X is greater than 7, and x is less than 2. Now, and problems have to have an intersection. Our answer is, where do they meet? Okay? So let's think about that. Here's my number line. Here's 2. Here's 7. If x is greater than 7, it's an open dot at 7 going to the right. If x is less than 2, it's an open dot at 2 going to the left. Where are both of those things true? They're not, right? You cannot have both of those things at the same time. So your answer? No solution. That would be no solution, okay? Last one. Let's say you have x is greater than 3 and x is greater than 5. Here's our number line. We have a 3 and we have a 5. Okay, if x is greater than 3, it's an open dot at 3 going that way. If x is greater than 5, it's an open dot at 5 going that way. It's an and problem, which means we need the intersection of those two. So what's your actual answer? Oh, you're so close. X is greater than 5, right? The overlap is all of this stuff. So where they overlap, where they intersect, is X is greater than 5. So your answer is an open dot at 5, like this. Isn't that fun? Bless you. So fun. Okay, I'm done. That's it. You have 15 minutes right now.